Hello everyone. Welcome to Malaysia Online Tuition YouTube channel. In this video, we are going to be looking at A-Level Pure Mathematics 1, Arithmetic and Geometric Progression Review Part 1. If you like and enjoy watching this video, then please give us a thumbs up. If you want to receive updates on our newest video, then please hit the subscribe button as well as the notification bell so that you won't miss any of our future videos. Right before we start, I would like to inform that we also provide private online tuition for Mathematics 9709, Physics 9702, Chemistry 9701, and Biology 9700. So, for question number 1, a ball is dropped from a height of 9 meters and it bounces up to 2/3 of its previous height after each bounce. For part A, find the height it will rise after 2 bounces. Okay, so for part A, we need to understand that this is going to be a geometric progression because of this. Up to 2/3 of its previous height. Okay, so this is the proof that this is geometric progression. And then for the common ratio, it is going to be 2/3. So now we have to define first, what is the first term here? Okay, so when they say a ball is dropped from a height of 9 meters, okay, so it doesn't bounce yet. So what we have to say is that Tn is after nth bounce. Okay, so meaning after the first bounce, T1, after the second bounce, T2, and so on. Okay, so in this case, our T1, okay, which is our first term, is going to be what? Okay, so after it bounces the first time, 9 meters times 2/3, so what is that? So that is going to be 6 meters. So when this asks after 2 bounces, so we can write T2 equals AR to the power, we can just write straight away 6, and then our R, which is 2/3 to the power of n minus 1, which is 2 minus 1. So this is just going to be 6 times what? 2/3. So the final answer for part A is going to be 4 meters for the final answer for part A. Next, for part B, calculate the total distance traveled by the ball when it hits the ground for the 10th time. So remember, they said total distance traveled. So this is very important for you to understand. The reason why is because you know that the ball is going to be dropped from a height of 9 meters. Okay, let's say this is the ground. Okay, and then the ball is going to be dropped from a height of 9 meters. Okay, so this is 9. And then it is going to bounce. And then it is going to be gaining a certain height, and then it will drop the same height. So in this case, you can see that after the first bounce onwards, will form the geometric progression. So for the total distance traveled, what you need to do is something like this. Total distance equals 9 meters, because 9 meters is not included in the geometric progression just now. Okay, the geometric progression starts with 6 meters, followed by 4 meters, and so on. So we have to add the 9 on our own in the beginning, and then plus, they said for the 10th time, okay, when it hits the ground for the 10th time. So you know that when it hits the ground for the 10th time, that means that is after the 9th bounce, okay? Because the first time it hits the ground is at the start of the geometric progression. Okay, so you don't want until the 10th bounce, because when if you take the 10th bounce, meaning that it already hits the ground 11th time, okay, for the 11th time. So that's why 9 plus S9, okay, because we want until the 9th bounce. Okay, so 9 plus, so for the geometric progression, the formula is going to be what? A, which is 6, okay, in this case. And then our formula inside is 1, I forgot to mention something. It's not S9, it is 2 times S9, because like I said just now, it will gain a certain height, and then it will drop or fall the same height again. So that's why we multiply by 2, okay? Please remember that. So now we can write 2, open bracket, and then A, and then 1 minus R to the power of n, meaning 2/3 to the power of n, which is 9, and then close the bracket, divided by 1 minus 2/3, you close the big bracket. Okay. So 9 plus 2 times what? Okay, the inside, you can see we have 2/3 to the power of 9. and then 1 minus answer, and then divided by 1 over 3, and then we multiply with 2. Wait, oh no, we multiply by 6 first, and then we multiply by 2. So, before we multiply by 2 just now, we have 17.5318. Okay, and then when you solve this, the total distance traveled, correct to 3 significant figures, is going to be 44.1 meters. Okay, and that's all for question number 1, part B. Finally, for part C, what is the total distance traveled by the ball if it continues to bounce in the same way indefinitely? Meaning, we want the sum to infinity. Okay, so as infinity, the formula as we know is a over 1 minus r. So our a is 6 divided by 1 minus 2 over 3. So we know that this is as infinity. But when we want the total distance, remember to multiply the result by 2 later. So this is 6 divided by 1 over 3, which is 18 meters. So for the final answer, total distance, okay, indefinitely, remember to put the 9 in the beginning. So 9 plus 2 as infinity. So 9 plus 2 times 18. So 9 plus 36, that is 45 meters. Okay. So this is the final answer for question number 1, part C. Next, for question number 2, a woman invests $500 in a finance institution at the beginning of each year that pays 6% per annum compound interest. Calculate the amount of money she will have at the end of the 10th year. So for this question, what we need to do first, okay, is not to straight away say this is geometric progression and so on. Okay, you have to understand that the woman put $500 at the beginning of each year, and she will also earn compound interest for the $500, for example, from the first year that she put inside the finance institution. Okay, so what am I trying to say here is like this. Okay, so let's say we define the first year as 2023. Okay, so for the year 2023, how much money does the woman have, okay, in the finance institution is going to be $500. Okay, so we can say $500. So end of 2023, how much is she going to have? Okay, so we can say the $500 plus the compound interest of 6% per annum. So we can write 500 plus 0.06 times 500. Okay, or another way for you to do this, okay, the easier way, you can just write 500 plus 500 times 0.06. So you can say this is just 500 and then 1 plus 0.06. Okay, something like this. Okay, so you don't have to expand this, or you don't have to find what's the value. You just have to look at the formula here. Okay, so now let's look at the next one, 2024. So for the year 2024, okay, at the beginning, okay, of the year 2024, how much is the woman going to have is 500 plus 500 and then 1 plus 0.06. Okay, the 1 plus 1, the 1 plus 0.06 is from the end of 2023. Okay, so then she put another 500, okay, in the beginning of year 2024, and then how much are you going to have after, at the end of year 2024, okay? End of 2024. So again, the same thing is going to happen. The 500 that she invested in the beginning of year 2024 is going to be getting the compound interest. So this 500 is going to be turning into 500 times 1 plus 0.06. And then the amount of money that she have at the end of year 2023 will be experiencing the compound interest for the second time. Okay, so then you will have 500, then 1 plus 0.06, and then this one is squared, just like that. Okay, so you can see this trend if you continue with year 2025 and so on. Okay, so let's see. Okay, let's just do one more. Okay, so that you can see the trend. So let's say we start with year 2025 now. Okay, still the same thing. Okay, you just follow the same trend. So she put 500, and then she have the 500 from the end of year 2024. which is 500 times 1 plus 0.06. And then she also have the 500, which has been compounded twice from the year 2023. Okay, so now when we look at the end of year 2025, the same thing is going to happen. The 500 in the beginning of the year 2025 is going to be compounded once. And then, okay, you know what happens next, okay? 500, 1 plus 0.06 squared. And then for the third one, 1 plus 0.06 and then cube. Okay, so how is this a progression? Okay, you can see, okay, you know that this is going to be a geometric progression. Okay, so the one that is forming the progression is going to be the one that is inside. Okay, so now what we can see here, we can take out the 500. And then you will see that you will have 1 plus 0.06. And then plus 1 plus 0.06. And then squared. And then 1 plus 0.06. And then cube. Okay, and then you can see that year 2026, year 2027, and so on. You will have plus ... later. Okay, so what we are going to do now is we are going to find the geometric progression for the inside. Okay, for the inside. So now this is the GP. Okay, so for the first one, we can write, okay, we can start here. Okay, why am I doing this first? Why am I showing you this first before we go to the progression? Because you need to understand that this is not the typical compound interest question that you have in the basic maths. Okay, this is the one that you will put a new amount at the beginning of each year. Okay, so for our A, you can see that it is what? 1.06. Okay, because from just now I've been writing 1 plus 0.06. Okay, so now I'm writing 1.06. So about the R, okay, we have what? The second term, which is 1.06 squared divided by 1.06. So definitely this is going to be 1.06. Okay. Now, how much money she will have at the end of the 10th year? So we know that end of 2023 is going to be the T1, this is going to be the T2, this is going to be the T3, and so on. Okay. So what we want right now is T10. Okay. So T10 equals what? Sorry, not T10. Okay, we want the total, right? So S10. Okay. And then after we get the S10, don't forget we have the thing inside the bracket. Okay. So if we want to have the amount of money that she will have at the end of the 10th year, you have to multiply by 500. Okay. So now for S10, we have A, which is 1.06. And then you open the bracket. And then 1.06 to the power of 10 minus 1. And then divided by 1.06 minus 1. So what will this be? 1.06 to the power of 10 minus 1 divided by 0.06 and then multiply 1.06. 13.9716. Okay. Something like this. Okay. So for the amount of money, okay, money, the 500 multiply with the 13.9716. So now the amount of money that she have at the end of the 10th year is $6,985.82. $6,985.82. So this is how you approach a question where the someone puts an amount of money at the beginning of each year while being paid a certain amount of interest. Okay, not dividend, interest per annum. Okay, compound interest. So that's all for question number 2. Now for question number 3. For the year 2000, the number of students intake for a course in one of the private colleges is 500, and each lecturer is assigned to teach a maximum of 100 students. If the students' intake increases by 10% every year, find the minimum number of lecturers required to handle this course in 10 years' time. So the moment you saw increases by 10% every year, okay, this is a clear indication of geometric progression. Okay, so this is a GP. Okay, so when they say increases by 10% every year, your R is going to be 100 plus 10% divided by 100. So that is going to be 1.1. Okay, as simple as that. when your R is 1, meaning that the value doesn't increase nor decrease. Okay. So if your R is greater than 1, then it is going to be increased by a certain percent. And if your R is less than 1, that means it is decreasing by a certain percent. Okay, every year, like that. So for the A, value of A, right? Okay, so for the value of A is the year 2000. So we can say T1 equals A, which is year 2000. So that is going to be 500 students. So now we want to know in 10 years' time. So meaning we want to know what is it in year 2010, right? So we can write T10. So what is T10? 500 and then 1.1 to the power of 10 minus 1, which is 9. So how many students are there in 10 years' time? So 1.1 to the power of 9 times 500, 1178.97. Okay, so logically, of course, you won't be having 0.97 students, of course. So you can choose either 1178 or 1179, as long as it is an integer. Okay, so now they said a minimum number of lecturers required, and you see that the lecturer can be assigned to teach a maximum of 100 students. So what you can say is 1178, okay, or 1179, doesn't matter, divided by 100. So this is going to be 11.78. Okay, so you know that the number of lecturers cannot be decimals like the number of students as well. So we want to have something greater than 11.78, because meaning one of the lecturers are not going to be teaching 100 students. Okay, he or she is going to be teaching 78 or 79 students only. So the answer is going to be 12 lecturers, the minimum number. Okay, so this is the final answer for question number 3. Moving on to question number 4, a piece of wire of length 8 meters is cut into pieces in such a way that the length of each piece follows an arithmetic sequence. If the lengths of the shortest and longest pieces are 10 millimeters and 15 centimeters respectively, find how many pieces of wire can be made out. Be careful with this question. The units are all different. The piece of wire has a length of 8 meters. The shortest is 10 millimeters and the longest is 15 centimeters. So the best thing that you can do now is to standardize everything into one unit only. Okay, so I think the best is for us to change into millimeters lah. Okay, but this is completely up to you. If you want to use centimeters, if you want to use meters, okay, up to you. As long as you are doing it correctly. So for this question, like I said, I'm going to use millimeters. Okay. So we have arithmetic. Okay, so they already mentioned, so you don't have to write that anymore. So we are going to start with the shortest. Okay, why? Because the shortest piece of wire is going to be the first term. So our A is 10 millimeters. Okay, we just write 10. Okay, because we standardized already everything to millimeters. And then we know that the longest piece of wire is 15 centimeters, which means we can write Tn equals 150 millimeters. Okay, 15 centimeters is 150 millimeters. And then they said the total length is 8 meters, meaning we can also say that Sn equals 800. Sorry, not 800, 8,000. Okay, because 8 meters is 800 centimeters. So that is 8,000 millimeters. Okay. So then we can change the Tn, which is 150, into the formula. So we have A, which is 10, plus n minus 1 times d equals 150. So we can say that n minus 1, not n minus 1, okay, nd minus d equals 140. Okay, so we leave it like this first. So for the next one, Sn equals 8,000. We can change it into the formula for arithmetic progression. So 8,000 equals n over 2 and then 2a, 2a meaning 20. And then again plus n minus 1 times d. Okay, I just realized that we don't even have to change this. We don't have to expand. We just leave it like this. Okay, and you can see that n minus 1 times d is the same thing that we have in the Sn. So what we can do now, we can change that into 140. Like that. So 20 plus 140. So this is 160. So n over 2 times 160. And then this is 8,000. So cancel, this is 80. So you have 80 n equals 8,000. So as you can see, our n, which is the number of pieces of wire that can be made out, we get it straight away. So it is what? 800 divided 8, which is 100. So we can say 100 pieces of wire. Okay, and this is the final answer for question number 4. For question number 5, if A, B, 10 is an arithmetic sequence and B, A, 10 is a geometric sequence where A and B are different, then determine the value of A and B. So for the arithmetic sequence, we can first say, okay, AP. So A and then B and then 10. Then for the GP, we have B, A, and then 10. Okay, so for now, what you have to understand here is that the arithmetic sequence will have D, which is common difference. So the common difference is going to be the second minus the first term, the third term minus the second term, and so on. So in this case, we have B minus A as well as 10 minus B. So from here, we can equate them. So B minus A equals 10 minus B. So we can make, for example, the equation, this equation, right, to be a linear equation. Okay. So in this case, we have negative A plus 2B equals 10, and this is the first equation. So the next equation that we are going to get is from the geometric progression side. So this will have a common ratio. So common ratio, like the common difference just now, second minus first term, but this time, second term divided by first term, third term divided by second term, and so on. So A divide B. So it can also be 10 divide A. So as usual, we equate them. So A over B equals 10 over A. So we have A squared equals 10B. So it looks like we don't have a linear equation for the second one. So we have to make the something as a subject from the first equation just now. So we can write A equals 2B minus 10. So now we can write 2B minus 10 bracket squared equals 10B. So we can expand. So 4B squared minus 40B plus 100 equals 10B. Shift this to the left, we get 4B squared minus 50B plus 100 equals 0. Okay, and then we can divide everything by 2. So we get 2B squared minus 25B plus 50 equals 0. So now we can try to factorize this normally first. This one divided by 2. So we can write 2B and then B. We can write 10 here. We can write 5 here. And then you can see 2 times 10 is 20. And then 5 times B is 5, right? Okay, so negative 20 and negative 5, you can get negative 25. So we have B equals 5 over 2 as well as B equals 10. But remember, they said A and B are different. So let's check one by one what the values are. So when B equals 5 over 2, so A equals 2 times 5 over 2 minus 10. So this is going to be negative 5. So when B equals 10, your A is 2 times 10 minus 10. You can see 20 minus 10 is 10. So this is not the one that you want because they said already A and B are different. So the final answer, A equals negative 5 and B equals 5 over 2. So these are the final answers for question number 5. Let's proceed to question number 6. The sum of the second and fourth term of an arithmetic sequence is 6, while the sum of the 10th term and 20th term is 102. Find the first term, common difference, and the nth term. Okay, so they said arithmetic sequence, so we don't have to write it anymore. So when they say sum of the second and fourth, you can write like this first. T2 plus T4 equals 6. Then when they say sum of the 10th term and the 20th term is 102, you can write T10 plus T20 equals 102. So straight away, from this point onwards, you change the T2, T4, T10, and T20 into the respective formula. For example, T2, it is going to be A plus n minus 1, which means 2 minus 1, that is going to be 1. So A plus D. And then the same thing plus a plus 3d equals 6. So now we have a linear equation. As you can see that 2a plus 4d equals 6. And then a plus 2d equals 3 for the first equation. Done. And then for t10 and t20, the same thing. A plus 9d plus a plus 19d equals 102. So this is 2a plus 28d equals 102. So you divide everything by 2, you get a plus 14d equals 51. Okay, as the second equation. So now you can see that the a for the second and first equation are already the same. So you can straight away subtract 2 with 1. Okay, or the second with the first equation. So we have a minus a to be 0. 14 minus 2, that is going to be 12. So 12d equals 51 minus 3, that is going to be 48. And finally, our common difference is 4. Done for the common difference. So then for the first term, we have a plus 2d, so that is 2 times 4 equals 3. So a plus 8 equals 3. And finally, a equals 3 minus 8, which is negative 5. So this is the answer for the first term. And the nth term. So how to find the nth term? So we write Tn equals a plus n minus 1 times d. So we change everything. So a is negative 5 plus n minus 1, and then our d is 4. So negative 5 plus 4n minus 4. And finally, the nth term of this arithmetic progression is negative 9 plus 4n. And this is the final answer for question number 6. Next, for question number 7, the sum of the first 16 terms of an arithmetic sequence is 784 and the 12th term is 70. It is given that the sum of the first n terms is greater than 1180. Find the least possible value of n. So sum of the first 16 terms, meaning S16, is equal to 784. And then for the next one, the 12th term is 70. So Tn equals 70. So change the S16, not Tn, T12, okay? So change the S16 and T12 into their respective formula. So for the case of S16, okay, the formula is n over 2, which means 16 over 2. And then you open the bracket, 2a plus n minus 1, which means 15, okay? D equals 784. So 16 divided by 2 is 8. So you shift this to the right hand side. So 2a plus 15d equals what? Okay, so 972, 98. Okay, so check. I don't want to use a calculator, by the way. Okay, so 2a plus 15d equals 98. So we cannot divide by anything anymore. So this is the first equation. So for T12, this is a plus n minus 1, which means 12 minus 1, that is 11. So 11d equals 70. And straight away, this is the second equation. So we can eliminate a by multiplying the second equation by 2. So we can say 2 times the second equation minus the first equation. So let's write the two equations first. 2a plus 22d equals 140 minus, and then we have 2a plus 15d equals 98. So 2a minus 2a is 0. 22 minus 15, that is 7. So 7d equals 140 minus 98, that is going to be, what is it? 42. And then our d equals 6. The common difference is 6. So finding the first term, so a plus 11 times 6, which is equal to 70. So 66, 70 minus 66, that is 4. So the first term is 4. So they said it is given that the sum of the first n terms is greater than 1180. So we can write Sn greater than 1180. So now we apply the same formula for the sum of the first n terms, n over 2. But this time we have the a and d. So 2a, that means 2 times 4. Then plus n minus 1 times the d, which is 6. Greater than 1180. So what do we do next? We can shift the 2 to the right hand side, and then we have n open bracket 8 plus 6n minus 6, and then greater than 2360. So 8 minus 6, that is 2. So we have 6n squared, and then plus 2n. Shift this to the left, so minus 2360 to be greater than 0. Okay. So now we have to solve this quadratic, okay? And I suggest you to just use the calculator. So number 5, and then 6, and then, oh wait, actually we can divide everything by 2. Okay, minus 1180 greater than 0. So then we will have the n to be what? Okay, before we solve the inequality. So we change, this is 3, this is 1, this is negative 1180. We get 59 over 3 and negative 20, okay? 59 over 3 and negative 20. So we can represent this, okay, like this, okay, minimum quadratic graph. And then on the left is the negative 20, and on the right is your 59 over 3. So we want greater than 0, meaning above the line. So we want this or this. But you know that your n cannot be negative. So n less than negative 20 is out of the question. Sorry, not out of the question, out of the option, okay? So what we want is n greater than 59 over 3. So the least n is going to be the next integer after 59 over 3. So as you can see, 59 over 3, what is that? That is 19.67 something. So the least value of n is going to be 20. Okay, because your n must be an integer. So that's all for question number 7. Finally, we have reached the final question of this video, which is question number 8. The sum of the first 4 terms of a geometric series is 5 times the sum of the first 2 terms. Find the common ratio which is positive. So please analyze them one by one. Sum of the first 4 terms, that means S4, okay, is 5 times S2. Okay, so what you should do now, you should change the S4 and S2 into the respective formula. So for geometric series, remember this is geometric, right? So sum of the first n terms, the first one is A, and then you open the bracket. And then, okay, so you know that you have 2 formula for the geometric progression sum of the first n terms, whether it is r power of n minus 1 or 1 minus r to the power of n. So for this type of question, right, it's up to you which one that you want to use, okay, no problem. So we can write 1 minus r to the power of 4, okay, close bracket, divided by 1 minus r. And make sure you are using the same thing for S2, okay, just for simplicity, okay. You can actually interchange, but why use a different formula, right? So 5, and then we have A, and then we have 1 minus r to the power of 2, okay, r squared, divided by 1 minus r. And then you can straight away cancel the 1 minus r, 1 minus r, you cancel the A, you cancel the E. Done. So you have 1 minus r power of 4 equals 5, open bracket, 1 minus r squared, close bracket. So you have 1 minus r power of 4 equals 5 minus 5r squared. Shift everything to the right hand side because we want the r power of 4 to be a positive value. So 0 equals r power of 4 minus 5r squared, and then minus 4. So now we can try to factorize this. Equals 0. So we have r squared, and then we have 4, we have 1. So to get negative 5, right, negative 5r squared, what we need to do, this is going to be positive, this is going to be negative. No, cannot. Okay, let me check. Okay, sorry, this is actually plus, okay. So when that is plus, meaning that we are going to use both of them minus, okay. So now r squared equals 1 and r squared equals 4. So then this r is going to be plus minus 1, but remember, when it is plus minus 1, meaning that the values doesn't change. Okay, the values don't change, so this is not the one that you want. You want something which is other than 1, okay, or negative 1 in that case, okay. So now you won't be getting the answer from here, so let's do this one, r equals plus minus 2. But since they already said, find the common ratio which is positive, okay, so the common ratio that you want is going to be the positive 2, not the negative 2. So for the final answer, r equals positive 2. So this is the final answer for question number 8, and that's all for this video, okay, about arithmetic and geometric progression review part 1. So if you have any question or any comment, please leave them in the comment section below. So if you like and enjoyed watching this video, then please give us a thumbs up. If you want to receive updates on our newest video, then please hit the subscribe button as well as the notification bell so that you won't miss any of our future videos. Thank you very much for watching this video, and finally, please take care, and I hope to see you in our future videos.